Hello, my fellow YouTubers. Part 2 on my water distilling. And right now, we are sanitizing the system. We are using this Vevor system. It's got a thumper. And right now we are sitting, hold on one second, let me get you plugged back in. It's what happened the first time. I ran out of power. We are sitting about 140 degrees. I guess we're about 15 minutes into this. By the time I filled it, right here we got cold water for the condenser. We got a thumper. The thumper is starting to get a little warm. You can feel a little bit. The steam comes out of the main fermenting tank, 5-gallon tank. Comes up, drops in the thumper. The thumper is like a second distilling, basically. So the steam will leave all its contaminants. It'll leave contaminants into the first tank, but it'll come up and come into the thumper and then leave any metals, heavy metals, contaminants into the thumper. Then it'll come out into the condenser, which is cold, and it'll start to drip out the very end there. Back to what I was saying is, why is it important for your body to be alkaline? Well, while my phone was charging, I went and peed on this one. And you can see my pee is darker than my saliva. This is with a pinch of baking soda, how alkalinity that is. And this is the 10 pH, which basically is a lie. It's not 10. It is sitting at 6.75 we determined. With a pinch of baking soda, it brought it up to a 8.0, which to me now looks more like a 8.5 alkalinity. Right? It's like 8.5. My saliva on my body is sitting more like a 7.25, which is a very good balance and not acidic at all. And my urine is sitting at a smooth 7.25 to a 7.5. which means my fluids in my body are very alkaline. This is a test that's for humans. Are you alkaline today? And pretty much this test for saliva and urine. And why is it important for you to have alkalinity in your body? Well, this is the important part. Your pancreas is controlled by your metabolism. Your metabolism naturally at the age between 27 and 30 will start to slow down. Your pancreas puts out secretions of alkalinity. So no matter what you do to your body or ingest or consume, your body itself will release alkalinity, which will keep your fluids in your body, which is supposed to be 80% fluid and 20% mass. And that's not 100% accurate either, because as you gain fat, your oils and your fat take up mass, and it restricts the intake of water. So basically, if you're supposed to be a healthy body, 80-20 ratio, and you got a fat mass on you, you got to discount that fat mass. So that means you might be sitting at a 70-30 or a 60-40. Depends on how much fat you have in your body, which we know that is not good, because you need the water. And why is it important to have the water alkaline? Well, the alkaline water puts a negative ion charge in your body, in your fluids. Why is it important for your fluids in your body to have a negative ion charge? Well, the way it works is that your muscle mass in your body acts like capacitors. They hold a charge. So when you go to move your arm, it takes energy. There's we're constricting your arm, and then we're putting it out. So it takes energy to do that. And different parts of your body to move takes energy. And that energy comes from these built-in capacitors. And these built-in capacitors are in your muscle mass, and they are like layers of mass that are like capacitors. And on these capacitors, all right, we're up to 150, 160. We want to get about 170, 180. And we should start to, very hot down here, very warm here, and very cold here. Nothing dripping out yet. Will be happening soon. So what happens in your body, the definition of a healthy body is a body that can reproduce healthy cells. And I urge for all of you watching this video to learn about your cells, your plant that makes healthy cells. And in order for a cell to maintain, to be a healthy cell, maintain a healthy cell, it has to be at a negative 25 millivolts. And if I take my hand here and if I smash it with a hammer and smash my finger, we're going to have a dilation in my finger. It's going to send out a signal, and it's going to require new cells to be built in that finger. And in order to reproduce healthy cells, new cells, you're going to have to be at a minus 50 millivolts to produce a brand new healthy cells. And if your body does not have the charge in the capacitors to do that, it will request it from other parts of your body. So it will go to different muscle masses like your legs, which are stronger, the strongest muscle in your body, and it will require for it to get them 50 millivolts. Funny thing is that I learned is that your teeth are like breakers. And your body's set up in different areas of this charge. And this charge comes from different muscle masses that will require to help a friend out, which another ligament or such and such, to reproduce healthy cells. So you have to be able to produce a minus 50 millivolts to produce a new cell. Now, I urge all you guys to learn the time frame it takes to make cells, whether it's skin cells, any kind of cell that's in your body, how long it takes. Now, very important, because if your body can't reproduce healthy cells or new cells, what happens to that organ? What happens to that part, that finger? Doesn't heal too properly. So, as we get older, we start to get osteoporosis because why? Well, I would think one of the main reasons is our body's very acidic. And in a natural way of our body to balance itself, it would go ahead and take calcium from your bones. And when it takes calcium from your bones or from your teeth, it starts to decrease what you have, your bone mass. And it all matters. So I want you to do the own research on your own side. Just putting this out there for you guys because I don't see it anywhere. And pretty much, it's very important to know your body. That's the key thing here. Know your body. We are up to 170 degrees. We should soon start to see some vapors come out this end. Feeling a little warm right here. got to know your temperatures if you're making beer or liquor. You don't want to make ethanol. If you go too high, you could make pretty much poison your body versus make what you're looking to make. So back to these alkalinity things. Very important. I urge everybody to learn more about your own body and what's keeping it alkaline and what's not. I'm not a doctor. I just do research. Love research. Very hot now. Very hot. So like I said, the whole premise here is to distill water. We're going to deplete it of its contaminants. We're going to distill it. And one thing I want to teach you about distilled water, which distilled water to drink is all not that good. Because what happens is we're unbalancing the water here. We're taking the trace minerals out of it, and it's unbalanced. So what would happen, the question to you guys is, if you were to drink a glass of this distilled water or any distilled water, how does that water balance itself if you were to drink it? Well, the answer is this. If you drink that water and consume it, what it would do is balance itself in your body. It would take the calcium and the trace minerals in your body out of its places, and it will basically balance itself. When it comes out, when you pee it out, it's already balanced because it stole it. It stole the calcium from your bones. It stole any minerals that it needs to balance itself out. And not a lot of people talk about that. One more thing I want to talk about before this thing kicks on and starts dripping out is how we're going to balance this water out once we make distilled water. Well, we're going to do it this way. We are going to use Himalayan salt. Now I have this block of Himalayan salt, and from my studies is that Himalayan salt has the same 65 minerals in it as our body does. And what we're going to do is set up a system to where this water, when it comes out from here, it will drip down the block of water, and it'll make its own little culvert down the center. And it'll pick up its own minerals from the Himalayan salt, and it won't be added as if I poured it in there. It will be added because it picked it up itself. So like I said, when that water wants to balance itself out in your body, instead of it doing it in your body and stealing calcium from you and giving you osteoporosis, stealing all kinds of iron and everything else it needs, it's going to take it from this salt, and it'll just make a crevice. So that is the plan on here. I hope you guys, we're up to almost 200 degrees. I think about 220 is where we're going to see this water start to drip out, and I'm going to keep you on until it starts dripping out. Now vapor is coming up and getting caught in here in the thumper, and then in the thumper vapors will build up until there's enough pressure in there, which will come down and go into the worm of the condenser, and then it will cool down, then come out back as as a liquid versus a gas. So this is a good chemistry thing to also be focusing on, is how to turn liquids into gas, how to separate the trace minerals, contaminants from the liquid, how to separate flavors, which is the skins of bananas and oranges, is where all the oil is trapped, which gives the orange and the bananas its flavor. And that flavor can be condensed into oil. And we could make one batch, which I guess we will do one time, is make a batch, and we'll get some oils. Now remember, oil and water don't mix, so you really can't mix the two. If you go ahead and try to mix the two, what you'll have is something called concentrate. What is concentrate? So let's go in the refrigerator and let's look at my grapefruit juice, for instance. Grapefruit juice will separate, and this says never from concentrate. So they're saying that's natural juice. So if you do have something from concentrate, that means that the concentrate would be where you separate the oils. Now you can see that this side's starting to shake. Still cold in there. Now we're getting up to about 210 degrees. I think about 220, I'm guessing. We're going to start to see a drip come out of the worm. There it goes. Look at that. Look at that. I just seen a nice little drip coming out. So what did I say? About 220. We're at 210. There we go. We're starting to see a little pump going there. It's starting its own little pump. There it is, see? Starting to pee out. So it's about 220, I read up, with distillers on when you'll start to see the water. You can see that there's condensing bubbles showing up on the worm. Now you can see we're starting to get a little flow. Pretty soon we'll start to have a steady flow. This will become a steady flow, especially when we get to 220. Now that water up top there is kind of getting warm, like hot. So let's get a little ice. That's why this pump is important. That's why it's important to have this cool down. So I'll have to focus on this pump as well. Now you can see it dripping. Got to cool that water down. Very important for the condenser to start cooling down. You can see some drips coming out as I put ice in there. It can't be hot water up there because it's defeating the purpose of a condenser. So the condenser is to be cold. And we'll do that by chilling it down. And we're up to 200. The temperature's dropped down by itself a little bit. And we're starting to see a little steady squirt because I'm cooling it down. Let's get a little bit more on there. So basically I can see now why the pump is essential here. Because what you want to do is flow the water, cold water through there. And that's what's needed for the condenser to work, is that water to be cold. So very important on using a distiller to be able to cool it down. Let's see if I can turn this pump on, pump out some water. And see if I can create an airflow here. Got water coming out. Alright, so this might be a submergible. But I don't know. I don't want to stick it in the water. But definitely putting ice in there will make the difference. Oh yeah, that's some hot water in there. So basically, the key element that I'm disregarding right now, or not focusing on, is the fact that that worm needs to be real cold. That it needs to circulate. So I guess if this is submersible, this would be filled with ice water. It would circulate this whole worm. And then that worm, you can see as it cools down, the vapors turn back into liquid. Look how that ice melting. I might have to put the pump on and circulate some water out of there. You can see as it cools down, you get a steady flow. Let's go ahead and suck out some water. And now we're going to suck some of this. Yeah. Yep, that's the key, is the worm needs fresh ice up top. Put you down for a second. It's kind of hard to hold the phone. Should be a steady flow coming out. Temperatures at 200. And I can smell the vinegar. So the vinegar is carrying over, but it is also doing what it's supposed to do on sanitizing the stainless steel containers. But you want to sanitize everything. The copper tubing, the worm, the ins, the outs. A 210. Bumper is very hot. Fermentation pot is very hot. Very hot. That probably has vinegar taste, but let's check. It's coming out cold. Let's put a test strip on it. This is distilled water. This should be very acidic water. They say that people who have cancer will run about a 5.5 pH, which stands to reason, because your liquids in your body are very acidic. Let's see, the top is very orange. Notice that the 10 pH is faded away, and my little touch of baking soda is solid. It goes to show you this is just because they added some electrolytes and some potassium drops. And we can see that this distilled water is sitting at about a 4.5. If you test your body and you're acidic like that, I would go get checked, because that's not healthy. So for first time out distilling, or even using a distiller, I can't say this is that bad. I would say using the circulation pump is the way to go. I don't want to ruin this by sticking this in the water, but I would think that I'm going to. Let's see how this works. So we're pumping out. I'm not getting electrocuted, so it is a submersible. And it is circulating. Ha! All right. Well, I'm circulating water. Let's stick some ice in that water. Grab some ice. It had to be submersible because we only had one line going in. So basically that cold water needs to circulate. So I want you guys to leave your comments. There's the cold water. You can see we're starting to get a good flow. Water is circulating, which you can feel a little warm water coming out, but that'll cool the whole thing down. Temperature still at 210. We needed to come up a little higher. That's maybe where my outside turkey fryer might come in handy to get the temperature up. I don't know, it seems to be working good. We're cooling it down. So it is a submersible. Oh yeah, look at that. hell? Don't do this with electric and water, guys. So on this pump, you can have it suck. So right now, we're should switch these to where the warmer water's up top. There's some things to learn here. So obviously, myself needs to learn here. So I know hot water rises. So basically this here should be where the cold water goes in. Here's where the hot water should come out. If it's warm up top, it should come out. Right now we are pushing water. No, we're sucking. We're sucking water out. Interesting. Well, you see the ice melting. You see the water dripping out there. Oh shit, we're gonna overflow here. So let's stop that. Oh God, I don't want to overflow. I just want to, there we go. We're sucking it down now. So we're decreasing. Let's put the plug back in. And now we're going to see it come back up. So I got a little to learn with. You can see the water coming back in. Now it's coming out. All right, so for first run, I want you guys to learn from my mistakes. You can see that we still have some good water coming out, and it's nice cold temperature. Pretty interesting. Not bad for the first run. Hopefully you learned something about this. And stay tuned. So what I wanted to show you on this pump, there's a plus and a negative. So I think if you swap that over, it'll act differently. Let's see. You can see the airflow coming out. So now what we're doing is we're pushing water out of here. We're sucking it in from the inside. I think my son just came out. He wants to cook some lunch. Might have to kill this video. Well, you guys got the gist. Hopefully you enjoyed what I say. Peace out. Leave your comments.